All right, so let's start looking at segments. All right, the first thing I would say to you is that a chord is a straight line that is drawn across the circle that touches the circumference at 2 points. So in the diagram, in the first diagram, the one on the left, you'll see the chord. That the chord is that straight line that is drawn across the circle that touches the circumference at 2 points. So this is the chord. Drawn across the circle, and it touches the circumference at 2 points. Guys, the diameter is a special type of chord. That should be easy to see. Now, a chord divides a circle into segments. A chord divides a circle into segments. The segment that is less than a half of the circle is called a minor segment. The segment that is more than half of the circle is called the major segment. So a chord divides a circle into segments. And the final point here, a chord divides a sector into a segment, into a minor segment and a triangle. So let me just show you that in action because it's important. So let us say we have a sector. Drawing it bottom right. We have a sector. Remember that the arc is part of the circumference. So this is the sector, this is the center of the circle. This is radius and this is radius. Now, if I draw a line from here to here, that line is called a chord. Because remember, the sector is coming from a circle. So that line is called a chord. And the chord divides the circle into 2 segments, but the chord divides the sector into a segment and and a isosceles triangle. So the chord divides a sector into a segment and a isosceles triangle. Why isosceles? Because this side is radius, this side is radius, and if you have a triangle in which at least 2 of the sides are equal, that triangle is called an isosceles triangle. Stay with me. So guys, hear it is. So in other words, the sector is 1 part segment and 1 part isosceles triangle. The sector is 1 part segment and 1 part isosceles triangle. Guys, the area of a segment is therefore the area of the sector minus the area of the triangle. The area of the sector is, of the segment is therefore the area of the sector minus the area of the triangle. The area of the sector is theta over 360 pi r squared. The area of this triangle, remember, if it's a non-right angle triangle and you know the length of 2 sides and the angle between them, the formula for the area is a half AB sine C. In this case, A and B are both radius, so radius times radius is radius squared. And the angle between them is the sector angle, which is theta. What I would say to you is try not to remember this as a formula, just try and remember this. That the area of a sector is the area of a segment is the area of a sector minus the area of the triangle. And this is because the sector is 1 part segment and 1 part isosceles triangle. Guys, let me do 13A and you do B. In 13, it says the diagram below is a sector and we are to calculate the area A the area, sorry, we're to calculate the area of the diagram below is a sector, and we're to calculate the area of the sector. Now, the area of a sector, so this is A, would be equal to theta over 360 pi r square. So this is 135 over 360 times 22 over 7 times the radius, which is 14 times 14. So this gives me the area of the entire sector. The entire sector is the shaded segment plus the triangle. 45 goes into this 3 times. 45, I think, goes into this 8 times. 2 into this is 4, 11. 2 into this is 2, 7. 2 into this goes 7. This 7 cancels this 7. So the area here is 3 times 11 times 7. 3 times 11 times 7. And so the area of this entire sector, POQ, is 231. And this is centimeters square. Stay with me. Next, we're asked to calculate the area of the triangle. Now, the area of the triangle, it's a non-right angle triangle. How do I know that? Because the angle there in the middle is 135 degrees. So in a right angle triangle, the highest angle you can have is 95. Sorry, is 90. So since it's 135, I know it's not a right angle triangle. So the area of this triangle would be equal to a half AB sine C. Guys, if you have a non-right angle triangle and you know the length of two sides and the angle between those two sides, the area of the triangle would be a half AB sine C. So it's a half times A. So A would be the radius, and the radius is 14. So it's 14 times 14. Those are the two sides. The sine of the angle between them, which is 135 degrees. This is 7. So the answer here is 7 times 14. So this is 98 sine 35. 98 times the sine of 135 degrees. So the area of the triangle is all right, 98. So the area of the triangle is 69.3. And this is centimeters square. Then we have to find the area of the shaded segment. Now, the area of the shaded segment is equal to, so the area of the segment is equal to the area of the sector minus the area of the triangle. So the sector is 1 part segment and 1 part triangle. So if I take the triangle from the sector, the piece that will remain is the segment. Now the area of the segment, sorry, of the sector is 231 minus the area of the triangle, which is 69.3. Using my calculator, let's see what we're gonna get. So we have 231 minus 69.3. All right. And our answer is 161.7, 161.7, and this is centimeters square. All right. So what we have to remember here, again, that a sector is one part segment and one part triangle, and that if we take away the triangle from the sector, what remains is the segment. All right, so next we're going to look at example 14. All right, same exact question, just different numbers. Now, example 14 says the diagram below is a sector of radius 21. So remember, the straight edges of your sector are radii of the larger circle. So the straight edge OB is the radius, so that's 21 centimeter. And the straight edge OA is a radius, so it is also 21 centimeters. All right, so the first thing we're told that pi is equal to 22/7, and we're asked to determine the area of the sector. Well, that's easy. Area of a sector is equal to theta over 360 times the area of the entire circle, which is pi r squared. And so the sector angle theta is 72 degrees over 360 times pi, which is 22/7, that is given, times the radius, which is 21, times the radius again, which is also 21. So 72 goes into 360 5 times, 7 goes into 21 3 times, and so my answer is 22 multiplied by 3 multiplied by 21 divided by 5. All right, so to get my answer, it's going to be 22 times 3 times 21 divided by 5. And when we work that out, our answer will be, so we have 22 times 3 times 21 divided by 5. The area of the sector OAB, the area of the sector is 277.2, and this is centimeters square. Turning the page. All right, next we're asked to determine the area of the triangle. All right, it's triangle AOB, which is an isosceles triangle, and the length of the two equal sides are, the length is 21 centimeter, and the angle between the two sides of known length is 72 degrees. So the area of that triangle, you have a non-right angle triangle, you know the length of two sides, and the angle between them, the area would be a half AB sine C. AB is the product of the two sides, the length of the two sides. So it is a half times 21 times 21 times the sine of the angle between them, which is 72 degrees. So I can just put this in my calculator and press equal. A half is, in my calculator, I can put that as 0.5. So this is 0.5. 0.5 times 21 times 21, the sine of 72 degrees. And so the area of the triangle is 209.7 centimeters square. And lastly, the area of the shaded segment. Remember that the sector is 1 part segment and 1 part triangle. If I take the area of the triangle from the area of the sector, what remains is the area of the segment. So the area of the segment is equal to the area of the sector minus the area of the triangle. So this is 277.2 minus 209.7. And so the area of the segment is 277.2 minus 209.7. So the answer here is 67.5. The answer is 67.5, and this is centimeters square. All right, and that's it.